Good morning, everybody. Is everybody ready to join day 2 of Plugfest? We're ready to get started up here. The show must go on. We got everything working again. So if you're interested in seeing today's testing, we'll be focusing on Ericsson's 900. We've only whiffed this twice today. We called you once Emerson, and now we got to get out the full Ericsson testing on 900. We're going to begin that testing here in a few moments. We're also going to have some demos from Landis here, and an unplanned edition. We're going to show two 1.4 megahertz carriers from two different vendors operating on the 900 megahertz band at the same time at the end of this session. So something new that was not on the agenda. The value of Plugfest. You see new things when people are around getting to work with each other. They try things out, see how it works, and it successfully works. So we're going to talk about that as well. First order of business for today is a slight technical correction. Yesterday, during testing, we were testing with 4RS modems, but we were not accurately depicting their success on our success screen. So we've updated our success slides to show 4RF. It's working great in our testing today. So this will be the data that we ultimately publish on UBBA's website and say tested at Plugfest and working in the 900 megahertz ecosystem. So with that, we're going to move into today's testing. We're going to do a little bit of orientation again, and in case people didn't see what we were doing yesterday, so everybody's familiar. So today we're going to be demonstrating devices on 900 megahertz, Ericsson's RAN system today. We'll be going through the similar set of Failover tests that we did yesterday, and then we'll also have some devices on CBRS. So since Ericsson is operating on 900, the other three vendors are operating on CBRS today for this testing. With that, can we go ahead and pull up the Failover screen? So we're pulling up the Failover screen. If you didn't see the orientation yesterday, we're going to do fault location, isolation, and system restoration tests with a whole bunch of devices on the network, all communicating to achieve an outcome to reduce a customer's outage. Later on in the testing, I'll talk more about Failover, but for what you're seeing on the screen, to be able to demonstrate what's going on the slides, I want to give everybody the opportunity to understand what's going on in the room. We have the master station, which is generating the screen that you're seeing are these Novatech Orions, these white boxes up here in the upper rack. They're tied to our wide area network, which is ultimately communicating to each of the RAN vendors. So in the room here, on the right-hand side, we have Motorola's 900 megahertz and CBRS RAN. So 900 megahertz coming out of the black antennas, CBRS out of the white antenna above them. We have Cisco broadcasting on CBRS using their white antenna. And then over here on the left-hand side, we have Nokia, the CBRS on the bottom 900. And then Ericsson is what we're going to be testing on today. Is that your 900 antenna? The 900 antenna is the white one here, and there's a CBRS one slightly behind the monitor. So we're going to continue to add to our list of successfully tested UE devices. Once the RF leaves these antennas, they're all going to these two racks of UE devices. So you see all the antennas with all the different pieces of user equipment. They are each communicating to a few field control devices that we have down here at the bottom of the rack. All three of these middle racks were put together by Novatech, physically assembled, and they're providing both the master station and the field equipment. The various vendors that you see called out, so Cisco, GE, Motorola, BEC, Nokia, Council Rock, 4RF, Hitachi ABB, and Multitech have all provided UE devices that we're testing here. So we'll be communicating with each of these UE devices, and then they are either talking to a physical piece of RTU equipment, or Novatech also provided two Orion MXs that are emulating RTUs for us as well. So all of the reclosers that you see out there are either physical or simulated reclosers running on the network. Anybody have any questions about what we're going to be showing today? And we're going to be going over the Failover schemes again. Okay. Well, with that, we will jump into testing. I'll call Jeremy up here again to show us what we're expecting to see and talk to us about what we're seeing live on the screen as we initiate our first test for day 2 of Plugfest.
All right. Good morning, everyone. So again, we're going to do very similar Flizzr from yesterday. This is actually the same scheme, different UEs that you saw yesterday morning if you were here. So what we're going to test first is our Zone A. Nope, Zone G, sorry. So we're going to go ahead and test Zone G. Faulting Zone G will go ahead and we see the fault occur, the outage, and we see that GE UE respond, and the breaker is closed, and we've restored power to Zone F. And that's it for this one. There's just one test on this one.
It's just one test.
Yep.
Well, as we work through the days, the tests are getting faster because we have more and more devices that we have completed. Do we want to, since it is flashing, we do have a comm fail. Do we want to comment at all on why we have a comm fail today?
We don't know.
We don't know.
Yes.
Okay.
We're still troubleshooting that comm fail right now.
So, as we have said, live testing, this is not about complete success, it's about trying things. We're still digging into that one, we'll report back.
It was working, came down, we're troubleshooting it.
Okay, we'll report back later on that.
Absolutely.
Ready to move on to the next test?
All right, this one was, I think, one test or two tests on this one, so we'll go ahead and do Zone A. This is testing Cisco on Ericsson 900 and Multi-Tech, I believe, on Motorola CBRS. So, good?
Is everybody familiar, since we did cover this yesterday, what we're seeing here? We're going very quickly through the demonstrations, but maybe I'll dig into it a little bit about what you're seeing on the screen. So the large, in this case, all red boxes that have numbers on the edge of the lines, those are our feeder breakers at substations that are feeding our distribution grid. Right now, we have normally open sectionalizing devices that are in the middle of those. Those are the green ones that you see that are making it into 3 independent buses. One of the questions that we received yesterday that I was just assumed everybody knew the answer to is, in most of the world, green is good and red is bad. And that's still true in the electric industry, but it's relative to a different thing. The red and the green is relative to safety or touch safety or being able to come in contact with the infrastructure. Red means that it is energized and that it would be bad for you to touch it. But it is good if we're in the business of having power flow. So a good source. So green is normally open, meaning there's not power flowing through there. There is energy on each side of that switch. It just has to close to pass by it. And then the other thing to point out, if you see the line is kind of thick and highlighted, you see the yellow line in the middle, it's kind of got a gray highlighting on each side of it. That means power is flowing in that bus. And to keep this just kind of in perspective of scale, one of those sections between those devices could have 500 to 2,000 customers connected in that area. So that's not each individual customer and service to each individual customer. That's a section of a distribution feeder bus. Different utilities and different areas of their service territory design the placement of these auto-sectionalizing devices differently, but it's typically, the lowest I've seen it go, and some utilities are talking about lowering it to 250 customers per segment. But there's many that are still operating with 2,000 in there. So this is a significant part of the power grid. There's megawatts of power flowing in that section. So can we redo this test real slowly and walk?
Yeah, we're going to do Zone B, and we can
so we're
do that.
Zone B. We're going to go in and simulate as if something happened.
So we see.
Yeah, go ahead.
Okay, so we see the Cisco saw the fault. We got that information, and now we opened and isolated the fault. So we isolated to Zone B, and then we closed in the tie to restore power to Zone C. So bringing back the majority of the customers that were out.
That's right. Does anybody have any questions from the audience? We're going to continue going through some testing here, since we have a lot of tests to go through in the testing, and they're all very similar to this. Yes? Can I give you a microphone?
What kind of latency are you seeing to go from red to green, or green to red?
Okay, well, we'll dig into that in a couple of different ways. So when we're talking about latency, there's 2 or 3 different things. We have latency of the device detecting the problems, the recloser. That typically does not, we do not initiate a flizzr scheme until we would usually achieve lockout on the recloser, which might be 10, 20, 30 seconds, depending on how it's programmed. To then, we have programmed in 5 seconds of delay in this so that you can see it. The communication network latencies, here's going to be contrived because we're all in one room, there's no physical cables in between. But you're probably going to be on the 100 milliseconds per communication message, and you're going to have to send 5 to 50 messages. So when we operate, we receive the message of lockout, the flizzr scheme goes and asks everybody, what is your status, processes its logic, a few milliseconds to do that, and then starts sending control. So you could have service restored in seconds. A lot of times, though, we will program in a delay that might be on the order of 60 seconds to 2 minutes. Usually the goal of a flizzr scheme is to restore service in less than 5 minutes from the initial outage or the initial lockout condition. And the reason is in reporting structure that turns it from a sustained outage, a SAIDI, in our reliability reporting statistics, into a momentary outage or a MAFI number. So does that answer your question, or we can get into it in more technical detail if you'd like to. Okay.
All right, we're good.
Any other questions in the room? Let's go ahead and continue testing.
And we can go to our last test. And we're going to fault zone A. And again, we'll see that outage, lost B and C and D. We'll isolate, and then we'll close in that tiebreaker and bring back B, C, and D.
Okay, so with that, we've added a few more modems that we've successfully tested. You know, the key thing here that we're showing in this testing is we're showing you a use case operating live, but the main thing is we want to show interoperability between all of the different RANs and all of the different UE devices. And so at this point, we're getting close to touching every one of the devices that are going to be faulted.
And I'm not sure if we explained that on the screen. The device name is there, but also what band it's running on. So if you see E900, that's Ericsson 900. N CBRS is Nokia CBRS. So throughout the test, that's how that's been shown. So you can know what they're running on and see.
Channel, or have you set up any particular PCIs for the
Yeah, so the question was, what are we doing for QoS in this configuration? During this Plugfest, we're on default QoS. We absolutely, next Plugfest, is going to dig into quality of service. But I would say it took a lot of energy to get all of this working. We're going to build from here into future things. And definitely the next one is going to be QoS and schedulers are probably the 2 biggest areas that we want to do a really deep technical deep dive. If you guys have things you want to see and suggestion, in the next week, we're going to be talking about what are we going to plan out and do for the next Plugfest and when that's going to occur. There's probably going to be something at DistribuTech. It probably won't be the technical in-depth. It's going to probably focus on allowing any vendor at DistribuTech to come and join the UBBA ecosystem by testing against infrastructure and doing a few demonstrations. But hopefully in the spring, we'll have another technical Plugfest where we'll dig deep into a couple of topics. And I think QoS and schedulers are the next ones. If there are other use cases that you guys are interested in, please speak up. If there's things that you want to demonstrate or are unique, we would love to show those. So as we continue to do testing here, I'm going to call on Gautam to come up and talk a little bit about the Ericsson 900 megahertz system and CBRS as well, and what we're showing here today. So let me get you a microphone.
Hello everyone, and welcome from Ericsson to this Plugfest. It's a great opportunity to be here, and we welcome our the chance to meet with so many of you. Let me spend a few minutes to introduce you to the Ericsson Lte Portfolio that we have here. What you see is the EPC is the set of the 2 or 3 servers in the corner there. It can serve about 50,000 devices, provides about 8 gig of throughput, which is adequate for a small utility. The structure of it is that you have about 2 Dell servers. You have a baseband which connects to radios, connects to both CBRS and 900 Android spectrum. The antenna you see here is for the 900 megahertz sector that we have here. And if you come back here and duck under, you'll see that we have a single CBRS radio which has a built-in antenna. And the good part about all this is that it's all connected to have a single combined system that can serve a utility. As the next thing, the components of the LTE system, although we have something that serves about 50,000 devices here, the larger system serving millions of devices is a containerized solution, which is of course not here, but that's what we deploy at our utilities. Any questions? Okay, if not, back to you.
Okay, thank you, Gautam. The next thing that we're going to do, so we finished up the Failover testing for this morning, so we'll go over here to our success screen before we cut over to Landis & Gear. So that's just not like what So this morning we've been on Ericsson 900 megahertz, and we've been able to test all of the various vendors' equipment through each one of those schemes. We've sent a message now to every one of these Huey devices that you see up here on the screen. And if they were not operating on 900 megahertz, they were operating in CBRS, and you can see the vendors that were operating in CBRS in this space. Now we're going to go to Landis & Gear, and they're going to show us a demonstration of how they're connecting their AMI field area network with the equipment here in the middle of the screen to Ericsson's 900 megahertz system for testing. It's going to take me a minute. We're going to have to log their computer into the WebEx and move the HDMI cable over to that system. In the meantime, I'd like to call on Scott Burke from Consolidated to come up and tell us a little bit about their modems while we get this set up. So, thank you.
Well, thank you, and good morning. And first, I'd like to say a big thanks to Novatech and all the engineers for getting this set up, because without their work, I wouldn't be able to stand up here right now. So a little bit about Consolidated. Consolidated is a U.S. company. We design, manufacture here in the U.S. We build industrial routers, outdoor enclosures. We build battery backup. We also have a full complement of engineering services for both mechanical, electrical design. We also have outside services for bucket truck and tower climbing. So very full opportunity, knowledge in the private LTE space. So today what we're talking about is the Intelligent E1500. It's our industrial router. It's a very flexible device with 1 to 3 LTE modules embedded inside of it. So it gives you flexibility with up to 5 SIMs. So you can have 5G, 4G, CBRS, Interix Band 8, FirstNet, narrowband IoT all in the same box. We also have wireline capabilities. We have a fiber optic interface or an MPLS router. For deployment out in the field, we've made it easy. I/O, serial, and Ethernet all in the same box. So we tried to build today, deploy today with tomorrow in mind. Thank you.
Yeah, thank you very much, Scott. Well, that stalling technique didn't work long enough for me. If Jason Kim can hear me, we're ready to do the Landis & Gear demonstration. And if you could come over to the demonstration area as soon as possible, I'd appreciate it. In the meantime, that's right, you have to be present to do your demo. While we're working on that, does anybody else have any questions? Here it comes. Thank you very much. There's your working microphone. Is this working? Yes. So, Drew, I'll introduce Drew here. You're going to do the talking while we do the demonstration.
I'll start.
Okay.
Hand it off. We'll talk a little bit about our solution. Daniel Robertson, who we met this morning, will be joining as well.
Okay. And can you do a little bit of a setup for everybody so they know what they're seeing? And I'll turn this mic over to Dan here.
Just 1 second. So give us a chance to. So we have just a few short slides to introduce ourselves. So we're Landis & Gear. We provide metering solutions for electric, water, and gas. Before I get too far into it, I do want to say thank you to John Hughes and Bobby Harris for the invitation. We were pulled into this just 6 weeks ago, so we had to pull together a demo on short notice. You'll see that we got it to mostly work. So I'm Drew Freck. I'm responsible for new business for Landis & Gear, specifically focusing on a set of strategic accounts here in the Midwest with Ameren. Dan Robinson, you met this morning. He's our Director for Innovation and responsible for private LTE. And then Jason Kim is responsible for our demo that you'll see today. Can we go to the, this is the right side. So, all right, next slide. So Landis & Gear, been a long-time provider of solutions for Ameren, dating all the way back to 1995, where we stood up a one-way AMR fixed network, primarily for meter reading. Go to the next slide. We've always had a multi-communications approach. Originally, that was one-way AMR. That's also included a private line carrier or public for utilities. Now we've progressed on to AMI mesh and private LTE. With that, I'll hand it off to Dan Robinson.
Hello again. So what we're going to see today, as Drew was saying, is a private LTE solution whereby we're going to show meters, we're going to show... Gotta eat the mic. Wow, that's a bit loud. Yeah, so we're going to show our cellular endpoints running on private LTE. Today we're actually going to see our collectors, which are mesh collectors using LTE as backhaul. You can see this operating. We also support cellular meters that run on private LTE, and also these network bridges, which are DA devices, which support LTE. When we talk about flexible cellular communications, we mean support for all of the public carriers on a single SKU device, on a single SIM, but also we support a full range of private LTE networking, including 900 megahertz Anterix, CBRS 3.5 gigs, 850 megahertz Southern Link, and FirstNet. FirstNet is not on a single SIM, but that's a business thing, it's not a technical thing. The way we do that is have the right types of modem, the right kinds of SIM, but also a network as a service solution, which allows us to provide that kind of capability, which is kind of unique, I think. Also, we have a consolidated head-end system called Command Center, and what that means is we can manage cellular endpoints, mesh endpoints, public, private, PLC on the same instance of the head-end system. So it's all consolidated. So our customers are mesh, and they want to add some aspect of cellular, they use the same instance. Next slide, please. Yeah, this is what our solution looks like. If you're kind of interested in our network as a service solution. Some of our customers are, some aren't. But what that means is we give a design for life type capability. What that means is we give you a service that comes along with the hardware that actually can be capitalized over the lifetime of the hardware, 15 or 20 years. That's 15, 20 years connectivity and support over the life of the meter or the router. And that can be capitalized if you want to capitalize it up front. And with private LTE, that's quite a popular option. We offer, single SKU endpoints that support all the public and private carriers with the appropriate bands and the right antennas and that kind of thing. What this all means is you end up with a more reliable, more resilient network, which is what everybody wants, especially when it applies to cellular. And from a future readiness perspective, We support further updates, currently at least 14 going forward. So you're not going to be stranded in terms of technology. Next slide, please. This is my last slide. This is what we're doing when we're talking about private LTE up to this point. So this is not just slideware. In fact, the first one we started with in terms of private LTE technology is 7Link. So we deployed an NB-IoT solution running on the guard band. We ran that through 7Link Labs. It's now with our customer. We were looking at different technologies to use there, but NB-IoT and the guard band was the most efficient usage of their spectrum. We then moved on to CBRS with UCO. We're running gateways on those DA devices, those bridges on Cat 18 on CBRS for them. That's what they wanted. So they bought the spectrum. With Anterix, it says Cat M meters here, and as of yesterday, that might be NB-IoT and guard band on that one. But we're going to figure out what the best solution is in terms of spectrum utilization for Anterix. We also have gateways and bridges. You're going to see that today. Jason's going to show you that. And also on FirstNet, our Cat 18 solution supports FirstNet. We're also looking at potential for meters on FirstNet. There's things we're looking at, again, to look at the best solution. So before, when we were talking about ecosystems, it's all about how do we build the best solution. And we do that by working with ecosystem partners and customers to figure out that, test it in the lab, test it in the field, POCs, and prove it all out. Because a lot of this stuff is new and it's all about proving and validating. So with that, I'll hand you over to Jason. You do the demo.
All right, so thanks everyone for joining us for this presentation. So our original scope for today's demo was to show the full end-to-end integration between our mesh endpoint all the way to our head-end system. However, due to some unforeseen challenges where our hotel network wasn't able to support the protocol 41, which is required for our user equipment to establish a backhaul connection with the server that's currently residing in our data center. So for the scope of today's demo, what we're going to really discuss is the connectivity of our user equipment using the radio access network that is provided by the Ericsson network, private LTE network. And the private LTE network is going to eventually get routed to the public network, and then it's going to reach our firewall at the data center. And that's what we're going to plan on showing. So with that, I'll stop the presentation and now start showing you some live screens. All right, so this screen that you're currently looking at is what we call built-in user interface that's available within our user equipment, the network gateway. So if we were to log in to our user interface, we get a series of different menu options, but for the scope of the demo, we're going to mainly focus on the menus that concerns with the modem activity. So if I go to the network configuration and navigate to the cellular tab, it has an option for us to quickly do a test against the modem as well as a SIM card that's within the gateway. And then the key piece that we want to highlight here on this page is this IPv4 address, which is a private IP address because we are currently working with the Ericsson private LTE network. This was an IP address that was allocated for the specific device's SIM card that is currently running on. So this is one piece that we wanted to just quickly highlight. And then to just show some actual network connectivity between our gateway as well as all our servers that is currently out in the data center. We're going to do a quick set of a ping test. Okay. All right. Bear with me for a few seconds. All right, so what I just did was the putty session, or the screen on the left side, is what's all the activities that are happening within the gateway, as well, and then on the right side is all the activities that are going to be captured at our server that's currently behind our data center. So if I were to initiate just a simple set of ping commands, you now start to see the traffic growing between the two, the gateways network as well as the server in the data center. And this proves that our connectivity, where the gateway is using the radio access network that's provided by the Ericsson private LTE, and it's getting routed to the public IP, and then the public IP ultimately routes this packet to the firewall at our data center. And that's what we're seeing on this session. And to just prove our point, on the screen on the left, which is the traffic monitoring for our gateway equipment, you can see that our device, the IPv4 address that we were just showing earlier, this 10.99.35.20, which is what's assigned to this gateway by Ericsson's private network, we see that the traffic for that is reaching our data center at the firewall, which has an IP address of the following on the screen. And then in return, we see from our firewall side, we are able to respond back to the message of this traffic by getting to this IP address that is listed as 68.188.56.155, which is in fact the public IP address that any traffic leaving the hotel network is gonna arrive with that public IP. So essentially what that screen was just showing was when our gateway was getting routed through the radio access network and then to the public IP, it showed up in front of our firewall with that public IP address, which is currently being generated by our hotel network. So I think that covers all the pieces for the demo, and I guess I'll give the mic back to you now.
Yeah, thank you very much. Can you leave that screen up for 1 second? So there was somebody yesterday that asked and said, hey, this demo looks very simple. It's got to be more complicated than that. If you want to, can you go back to that screen? We'll show off Dan's handiwork here. This is Dan's diagram of everything that you see working here at Plugfest and how it's connected. I'll give you a little bit of intro and understanding about how things are connected. I'm going to have to stand right here to stay on screen. And you can see all of the EPCs that are out in the cloud that are at various data centers that we're using for the public network. So when we're talking to US Cellular, when we're talking to AT&T, FirstNet, all of those, Cisco's EPC, those are all those blue dots that are up at the top. All of that comes across the internet, and we're fiber connected to the hotel's internet here. And we come into Cisco's main router, where they are doing lots of different routing functions, but in some case, PAT, NAT, whatever we need to do to get to each of the 4 blue RANs that you see right here, that you're seeing demonstrated in the room. You see the wireless connections to all the UEs, which are in blue. Further over, and then behind that is the network that exists behind all the UEs to talk to all of the virtual RTU equipment. And then over here on the left, also connected to Cisco, it is the Orion head-in and our test software. Anybody have any questions about this, or concerns, or anything before we wrap up Linus and Gear's demo? Okay, with that, we're going to wrap up and then we'll move on to our next test.
I just want to say thank you to everybody for the time. Thank you to Ericsson. Thank you to Bobby and John. Really appreciate all your support. Thank you.
Okay, with that, big round of applause. With that, we're going to switch the video cable back. If you can take that back to the back, and we'll put our success screen up. And then we're going to go to testing before we do that. So we're going to go back to live testing and do failover testing. So this was the other test that we did last time, where we're going to show failover of a UE device going from private infrastructure to public infrastructure. And so this is the use case where by following the global cellular standard, we now have access to a lot more different RAN infrastructure. So you can use FirstNet, you can use AT&T's public network, you can use US Cellular, you can use any different network that you want to have in existence that is in your area to fail over. And the key thing is here, we don't have to give you a new IP address or change the security model, i.e. this can all basically happen in a few minutes. So keep in mind, this is going to take up to 5 minutes to occur, but if this was happening the way that we do it in most networks today, you would have to drive out there and go put in some new radio device to make that happen. So this test will take a fair amount of time. Jason, you want to set up the search? I've only said it 500 times. So we're going to set up and discuss, what we're doing here for the testing. We need the other microphone. Oh, it's right here.
Oh, sorry. You can go down.
Hopefully we'll answer your question. If not, go ahead and ask it.
All right, so what we're doing is right now these devices are running on Ericsson 900. Ericsson is taking their 900 down, and that was quick. And now we show that we are able to communicate over Ericsson 900 through those devices. And so what we do is we shift what we're trying to poll with DNP, and we start polling a different IP address that should be the public IP. So band 14, FirstNet, so that one's already shifted. That's a dual radio, or dual modem router. Yeah. So it shifts quick, active. The other two, we're polling with DNP.
Well, let's slow down. So the question was, how are we monitoring the network to know when it is going down?
Yep.
Different UE devices do it in different ways. We have several different scenarios that are being done here. The question is, are we using BGP? That's one of the ways. I don't know if that's Cisco's. Okay, they're using an SLA policy that's monitoring. So it's doing health. I'm assuming ICMP health checks out to the head-end server, and when it detects the loss of that health check, it go ahead and switches the route in the local UE device. Some of the modem manufacturers are just looking at the band status. So we've seen that one cut over. Okay, back to Jeremy and testing here.
I believe the 4RF is a single radio, so it's going to take some time, and the GE is a single radio as well. So they can take multiple minutes before they actually come back up. So we're just going to leave it and let it run?
Yeah, we're going to leave it and let it run. We're going to call on some vendors to come up and share some more information with us. Before we cut to that though, does everybody understand this concept of one modem versus two modems and active and failover? I know I talked about this a lot yesterday, but I think it's important if we have new people here. So a lot of devices, you have the say router, the UE with all of the serial ports and Ethernet ports, and they have one LTE modem built into them. However, they can have two or more SIM slots connected to them, and when they lose one carrier, the private network in this case, they can reinitiate the modem and change over to a different carrier, which means they're changing frequency bands. Sometimes we're changing the protocols and how that communicates. We're having to reattach and recommunicate. And so, in this case, the two bottom devices are having to effectively reboot their modem. They don't reboot the entire device and reload their profile to go to US Cellular and AT&T, connect to their public network. Beyond that, we have to reestablish any security that we're doing, so IPsec or other things like that. We also then, what we're showing here is DMP traffic. This is what the master station is seeing. We also have to reinstantiate those DMP sessions. So that can take seconds to minutes. And if somebody wants to dig into this deeper, we can go through each of the delays through each of those segments. In the meantime, Mike, who are we calling up to share? I would like another vendor to come up. Who was the next one? Who's that? I need my cue card from the back. QNet. Ron.
You're up.
Join us and like to hear a few things about your devices. So here's the microphone.
Okay. Can everybody hear me? Perfect. Well, thank you all for coming. Really appreciate it. And I want to thank Anterix for allowing us the opportunity to introduce you to QNet. We've been working with Anterix for a couple of years now. We did go through significant testing with them. We were among the initial charter active partners with Anterix. What QNet does, we're based here in St. Louis, so if you go halfway to that other small company here based in St. Louis, Worldwide Technologies, you'll find us. So we're halfway the way out there. But what we're working with is delivering secure network overlays into critical national infrastructure. So we have a lot of different applications, utilities, and then some. And the activity that we have, as I say, is to install and implement a secure network overlay. We're also working with Intel. We're in their MRS program, or the market-ready solution that we have. Just a few, about 100 of those solutions exist there. And what we're doing then is we see all this equipment back here, and we think about interoperability. As a network overlay, we have interoperability just nailed. We don't have to change the endpoints. We don't change the network. In fact, the system just drops in, snaps in as a plug-and-play device. It comes up, does everything that it needs to do. In fact, the endpoints don't even know that it's there. The network doesn't know that it's there. And we do what we need to do device to device to make sure that we can secure that infrastructure. So the devices that we have been tested. So this is the kind of device that we have that snaps in. Could be DIMM rail mount or something else. And they've been tested by EPRI. If you go into the Knoxville lab, you'll see the QNet devices sitting right in the middle of their lab. As I mentioned, we've been tested by Anterix. Also worked with US Cybercom, as well as doing FIPS certification with NIST. So with that, I think, as I say, just wanted to introduce you to QNet. There couldn't be anything simpler to secure the networks. These are drop-in. They don't require any kind of patching, updating, changing along the way, which is a really different concept for such a strong kind of national grade security. And because they are strong, NSA declares them as being quantum compute resistant, they're going to snap in, plug and play, and you just forget them for years, if not decades to come. So with that, I thank you for your attention, and if you have any questions, you can either ask now if we have time, or we live just right next door. Just hop on over there, and we'd love to talk with you. Thank you.
Hey, thanks for sharing. And I wanted to highlight that we now have successfully completed this test. While we were hearing Dan speak there, we were able to catch the last two devices moving over and activating on their public carrier network. So you get a feel for how long that conversation takes. The next test that we're going to show you is two 1.4 megahertz carriers working next to each other in the 900 megahertz band. So we're going to go ahead and cut over on the WebEx display to that. And in the meantime, I'm going to surprise Jeff here and call him up here to stage to embarrass him a little bit. and have him talk a little bit about the Cisco CBRS WAN solution, and I will give you this microphone.
All right, thanks, Matt. I don't see WWT here, but Cisco's RAN is here because of WWT. So they do a lion's share of the integrating for us in the utility space. So unfortunately, they're not here to hear the thank you, but thank you to them. They're actually hosting our core in their lab down the road. So sure, turn the page for a moment on the sense. I'm sensing this is our opportunity to give a commercial. Obviously, this is a RDA gateway router, if you will. One thing I wanted to pull forward, if you didn't know that, is this particular platform called the IR1101 is modular solution, stackable, and so on and so forth. I bring that up because the modem modularity is such that it's the same modem that we're testing with these frequencies, whether it's FirstNet, Anterix, CBRS, and so forth. That same modem is used in our vehicle router, in our substation rack mountable router, and so on down the road. So it's the same hardware we use due to the modular aspect of it. You get the same security architecture, the same operational piece of it as well. Extends across our whole ruggedized portfolio. And so I think that's something that tends to differentiate ourselves, so I want to pull that up since this appears to be a Cisco commercial. But other than that, big thank you to not necessarily the men behind the curtain, but the men behind the red case here. So as you might imagine, this was a lot of work for these folks to put this together. And both the vendor community and the client community gets a lot out of knowing that this is real, right? That this isn't just vendors claiming things to be. And with Matt's leadership, we've been able to test it in the past couple of weeks. So rather than just waiting to see how it all goes at Ameren. So, gentlemen, thank you for your hard work. And I think now I'm going to give it back to Matt so he can pick on somebody else.
That's right. Well, we're not going to pick on anybody, but we're going to show some unplanned live testing, which always, what did they tell me? Don't go off script, since they gave me like a 16-page script for this. But guess what? We're going off script. We're going to cut live to looking at something that we've been testing over the last couple of days. So what you're seeing here is a spectrum analyzer in the room. You see the entire 3 megahertz spectrum band. I'm going to try to stand here so I can stay in video frame, but also point. So everybody on the WebEx should be seeing this live as well, but you see, well, I can't stay this far away. I'm going to have to walk over here. So sorry I'm going off screen, but you see down here at the bottom the spectrum scale, and you can see right here is our 3 megahertz of spectrum that we're utilizing that Anterix is offering in the marketplace, and you see the 2 different carriers. Now that we talked about yesterday, or if you haven't seen Spectrum Analyzer, I'll give you a little bit of orientation. And I'm going to guess here, the green line is minimum hold, and the yellow line is kind of the real-time normal sampling value. We can also turn on a maximum hold at some point in the carrier if we wanted to. So what you're seeing here is the 2 different carriers sitting next to each other with a little bit of a guard band. That's where we had the NB-IoT signal inserted yesterday in the middle. You can put NB-IoT in the guard band either below or above, or in this case between your operating signals in the system. And I have no idea what this carrier is here. Maybe it's does anybody know? Might be an adjacent, it looks like a 25 kilohertz carrier. It looks like a Lmr carrier sitting off to the side. So see, other people can still use their spectrum too, and we'll pick them up on the spectrum analyzer. But I'm not, it's probably these wireless microphones and why we've been operating there. So what I do need to cue about is who's on which side. Who's on, so Ericsson, as they're sitting in the physical room, is in the upper band here, and this is Motorola's carrier in the left-hand side. So while this is operating, we also have, this was operating at the same time we just did all those tests on Ericsson, but also prove that this is working. Motorola was running some live Lmr calls. So I'm going to come up and share a little bit about the Lmr calls that we had going on. Again, not really part of the plan, so we didn't have any demonstration up here. But to make sure that we weren't having QoS issues, I'm going to come back in the middle of the screen so that I can be back into the video frame. But so that we can make sure that this is working, they were also carrying on live Lmr Calls. So you want to share a little bit about that? A couple minutes, I'll cut you off.
Thank you, Matt. So I think what Matt explained, right? In 1.4, when Ericsson is doing all the grid use cases, what you just saw. The other 1.4, I think we are live with actually our MCPDT call, multiple devices by our booth. You can see it is all live, right? Marcelo can demonstrate all of that. There are kind of the Motorola devices, truck radio, BYOD devices, and also the CBRS is also active. So it's a group call going on with 900 and CBRS together. It's live, right? So I think what it tells is really that could be multiple tenants within the 3 meg, 1.4, 1.4, or could be multiple vendors doing the different applications as well. Right? So I think as I speak, I think one of my colleagues is just kind of doing some of the live demos over there. So please stop by, when it's active with multiple LTE kind of going at the same time, multiple PTT calls, group calls, CBRS and LTE together. Yeah, so this is one of the kind of the CBRS device, Motorola device, dual CBRS carrier LTE dual SIM. And similarly, we have some the clock radio that's doing the 900 amp-rates. Then we have also the converged device that can do the LMR and the PDT. So all the group calls that's going on actually is all the MCPDT calls, right? 900 and CBRS together within that 1.4. Simultaneously, concurrently, while Ericsson's 1.4 is doing for the grid assets.
Okay, thanks for sharing that information with us. Next, I'm going to catch a microphone real quick. I know you're supposed to drop the mic when you're done, but that's a little too figurative. So, Brian, you're going to come up and share a little bit about FirstNet. FirstNet was one of the public networks, or I guess maybe I shouldn't call it public. I'll let Brian describe it. But it's one of the carriers that we are not hosting within this facility. We're using the U.S. nationwide network for delivering that traffic. So, Brian, you want to share?
Yeah, absolutely. Thank you, Matt. So, I'm Brian Huey from AT&T. I represent the energy and oil and gas side of our utility practice, focused on IoT as well as advanced applications. What we're demonstrating here is we have 2 devices that are utilizing a FirstNet SIM that are connecting to our macro network that's outside the hotel area. And once you're qualified to be on FirstNet, it is a separate network and from AT&T. So it is authenticating to a separate core network that's encrypted end-to-end. So we have encryption from the modem all the way through the network back to where the data traffic is terminating. So that's the first thing to know. All of these devices that you're seeing here that have the FirstNet SIM in it, they have a LTE priority data marker attached to the packet. So in these situations where you're failing over from private LTE over to FirstNet, your traffic is marked with a QoS marker that's only for FirstNet subscribers, so we guarantee that the traffic is, going to make it over the wireless network and terminate into the core. Boy, how much did they hear? So a couple of unique things. I was coached, let's talk about some of the stuff that we're talking about at the booth. So the first thing to know about FirstNet, I already covered. You get the priority data, your traffic gets through. A couple other key inventions or enhancements to the FirstNet network. We do have the ability to authorize through the FCC to transmit at 1.25 watts of power. What that means to you as a utility is we can extend coverage from our base station out to about 15 miles. So as you're building out your private LTE network, you can deploy these high gain antennas, high power modems, and communicate back to your critical infrastructure. That's another key element. The other element I'd like you all to know is once you're authorized to be on FirstNet, and so as a utility, you are authorized to be on FirstNet, so you can contact us and get an account set up. When disasters come in, or events come in, or a local event is declared in the area, you can call us and have a SAT cope deployed free of charge, or a deployable asset. So if a tornado comes through, a hurricane comes through, you can contact our response operations group, and we must have a deployable asset on site and restore communication. So that's not an AT&T initiative. That's mandated by the U.S. Congress. So we must deploy and report those metrics. Pause here. Any questions? No? Okay. I think if you have any other questions, please stop by the booth. We're built out to 99% of the country, so happy to take those questions.
Yeah, thank you very much. Thanks for sharing that information. We're down to two things, and we're probably going to end the session a little early. Hopefully they're going to get lunch ready for us early as well. So we know that we all would like to get out of here at the end of the day as quickly as possible. So one more thing, I'm going to also ask Jason from US Cellular to come up and share a little bit about US Cellular solution. He shared a little bit about it in the session yesterday. And then after that, since we are done testing, and Jeremy's not going to kill me if somebody unplugs something or steps on something, I'm going to invite everybody up to take a close look at the equipment. You can talk to your equipment vendors about what they have in their WAN and core cabinets, as well as you can look at the physical UEs. If you have questions about how the test bed setup was set up, we'd love to answer those questions. And this is Plugfest, but we're also going to use this as the UBBA test bed for moving into future activities. So, Jason, you want to come up and share a few comments? You get a couple of minutes.
It's fine. I didn't have anything prepared. They literally just grabbed me out of the hallway and said, "Come over here and say a few things." So this is totally real. So, James Rose with US Cellular. If you were able to attend the session yesterday, the point of the message for US Cellular in the utility space with private networks is essentially to say that no two utilities are going to approach private networks exactly the same way, and that's okay. As a carrier, we think it's really important. Sorry, it's really loud here, I guess. So as a carrier, we think it's really important that we take a locally guided approach to the technology that the utilities are looking for. And that can look very different from one utility to the next because, as you know, topography, geography, everything's going to be different. And we look at that from a RAN perspective, from a core perspective, consultatively as well. We look at the different services that utilities need to stand up and operationalize those types of services. So that's really important, key number one. Number two, as a carrier, we're actually very agnostic when it comes to partnerships. As the private network ecosystem starts to identify itself, we're seeing a lot of different system integrators, core providers, RAN providers, etc., that are thinking about this space, and US Cellular stance in that is great. We want to partner with folks. We want to help individuals understand from a network operator's perspective how they should be looking at this. And we have over 30 years of experience running a network. Therefore, we're helping them kind of guide that thought process as well. Last thing I'll say is, as a carrier, we take a very similar stance in the industry as far as data priority. We look at utilities as mission critical infrastructure. So connectivity is definitely focused on that as far as data priority is concerned. I think that's all I got, Matt. I don't know if there's anything else you're going to touch on.
Nope. If there's anything technically that's unique, that is different, maybe I'll dig a little deeper because we've had some one-on conversations. But one question that comes up all the time is, and I'll give Brian from FirstNet an opportunity to talk about this. When we talk public and private, there's a big question about how we work together in doing this. And the one big area of question or overlap is around SIM cards, IMEI numbers, and we've talked about the capability that if you are wanting to build out and you need to accelerate and deploy devices today, you can, technically, if a carrier is willing to work with you, and I'm going to twist Jason's hand a little bit here, to say those numbers could be hosted on somebody else's core. It could be on Southernlink's core, it could be on US Cellular's core. Your devices can come up and work and operate in the world if you need to go deploy devices today, meters and such. And then as you build your private infrastructure, there are ways, not the cleanest ways sometimes, but to move those SIM card hosting from somebody else's infrastructure to your infrastructure so that you can accelerate that initial deployment. Everybody says, hey, this is a great idea, but it's going to take me 5 years to get all my RAN built out. Yeah, we understand that's going to take some time. Here's a partner that is willing to work with you in how we can go about being innovative in deploying that technology. So there are multiple options in that space. So
yeah, and so the thing, thank you for saying that, Matt, and I couldn't agree with you more. I probably couldn't have said it better than you. So the thing I'll add to that is, you know, the approach doesn't have to be 1, 2, 3, or 4, and that's it. You know, I showed various ways that you can approach the private network space. It can be a gradual evolution as well. And so as you're saying, Matt, you're not going to just have a RAN stood up overnight. It's going to take years, and you're, you know, operationalizing a core and acquiring MZs. Like, that's not going to be a fast thing. So what we, you know, the way we look at that as a carrier is we want to help you, guide you, not just with what we can offer you directly, but we're going to also help guide you to transition that to your own network itself. So the idea here is to reduce truck rolls, reduce the amount of labor and time and cost that goes into that transition.
Yep. We have to make sure that we are not going to ever have to go touch those SIM cards. If we have to do that, we have blown up our use cases. I can tell you that from a financial standpoint. So let's find ways to do that over the air.
100%. Yeah.
Okay, thank you. Well, with that, we are mostly done with things that are going to happen in this room with Plugfest. I keep saying we're almost done, and then I'm going to add one more thing. The next thing that I'm going to add to it is I want to call up everybody who made Plugfest happen day in and day out and work their butts off on this, and they're going to be totally embarrassed that they're going to have to stand up here with me. So, Matt Eschpeter, Jeremy, Sean, Dan, Brandon, and Gautam, and yep, come on. Everybody who's been here with every RAN core, who's been here in the middle of the night. Where is, and I'm apologize, I'm missing the name, Cisco RAN. Yeah, we need Mauricio. Mauricio, are you back in your booth? Can I call you one more time to come up to the stage and change your 900 megahertz carrier? I've only done this like 55 times. If anybody knows where Mauricio is, send him this way because we're going to give him a big round of applause. And so, if everybody could give these guys a great big round of applause. These are the guys who made all of this Plugfest happen. They've been here day in and day out since Monday. They've worked on this extensively. Come on, Gautam. Come on. Yeah. These are the guys that have been working on this. They've joined calls every week, twice a week, 3 times a week at 7:30 a.m. Five times a week.
At least.
I never know that you got to 5 times a week.
There's 3 on Wednesdays alone.
No, 3 on Wednesdays alone. For the last months, this is what it has taken to make Plugfest ultimately happen. I'd like to say thanks to Mike Brozak, who's also standing behind the microphone, who's been my cue card guy, giving me all the details on time and things. So thank you guys very much. I hope somebody got a really awesome picture, high quality photo of this. We will upload this to UBBA's website to say, take a look at the industry and think about the impact. Everybody's like, well, we've seen all this stuff just works. Have you seen all this stuff work? I haven't seen all these things work in one room at one time. I would tell you, going into this, we're all very scared about the RF aspects of this. Like, could we operate all these carriers in one place with all of these devices on one rack and it all worked flawlessly? I can say, well, there were a few things we had to work through, but everybody worked great with each other. I want to compliment everybody for, I never heard one raised voice here. I heard a few on some phone calls. One raised voice about this activity. I really appreciate that. Thank you guys so much from the industry for all that you guys are doing. I know it's a lot of hard work in doing this. So you can all smile too.